it. Ashton, what did your group do to build the number 126? Glenda, thank you. Okay, so we took a 100s flat, and then we took 2 10s, and then 6 counters. Give me a Me Too signal if your group modeled it in basically the same way. Did anyone do anything different? Well, what did your group do?
We took 10 of these and
10 of what are these?
These 10 rods. Then 2 more to make of the 10 rods to make 100. Then 2 more to make the 20.
All right. So hang on, I'm going to draw this. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We got 10 rods first. And then you told me you had 2 more?
Yeah.
All right, and then what?
6 counters.
6 counters. Interesting. It's an interesting way to think about that. It does change colors, it's fine.
But that's so cool.
Let's start here. How many 100s are in the number 126? How many 100s are in that number? Elena?
10.
There are not 10 100s. Nope. How many 100s are in 126? Harper?
1.
There is 1. 100. How many 10s are in 126? Bella? There is not 2 10s. There is not 2 10s. Logan, how many 10s are there?
There is 12.
There is 12!
It's a bit.
But I understand, Bella. You're looking at this model right here. And you're sitting here like, wait, Miss Miller, I see the 2 10s are right there. But Logan says 12. Where are those 10s? Where are those 10s, Harper?
They're in the 100.
They are in the 100.
Because 100 is made of 10 and 10.
Yeah. 100 we know is worth, it has the same value as 10 10s. And we can see it in Will's model. We had 10 10s there, which is equal to our 100s flat. And then we added those extra ones. All right, let's look at our next question. Oh, how many 1s are in 126?
Ooh.
How many 1s are in 126? How many 1s are in 126? Gwen? 126, but wait, Gwen. There's only a 6 in the 1's place. Are you sure it's not 6? How do you know that?
Because you can make it 100 out of 1. You can make a 10 out of 1.
Yeah, it is 126 1s. There is 126 1s. Now, it would be incredibly annoying to make 126 out of 1s. Right? That would really be a bummer.
That would be like a lot.
It would. So we've made it a little more efficient in the sense that we have groupings of 10s and 100s, so it can be faster. But could I do it completely out of 1? Yes. Yeah, I could.
It would take like 30 minutes.
I could 100%. All right, let's try another number. I want you to make this number 373.
Oh, that's going to take a lot.
373. Go ahead and build that number. All right, how did we build it? How did you build it? Elena, talk to me. How did you build 373? 300s flats. And 7 10 rods. 2, 3, 4, 5, 6, 7. Okay.
And
then 3 counters. Give me a Me Too signal if you built it the same way. I think this is a pretty normal way. You've done this probably in 2nd grade or even some in 1st grade.
Yeah.
Let's go through our same question. How many hundreds are in 373?
200.
No, thank you. How many hundreds are in 373? Devin? 300. I could also write it like this. How many tens?
Ooh.
This is where it gets a little tricky. Not impossible, but a little tricky. How many tens? Well, you just have to think. Lincoln, how many tens?
37.
There are 37 tens, but Lincoln,
Yes.
there's...
Yeah.
There's only 7 tens in my model. So where is the 30? You told me there's 37 tens. Where are they?
The 100.
They are in the 100. How many tens are in 100? How many tens are in 100? This is not a trick question.
No.
Shelby?
10.
There are 10 tens in 100. That means there's 10 tens in this 100. That means 10 tens in this 100. If I skip count, 10, 20, 30, and then add my 7, I've ended up with 37 tens. How many ones are in 373? How many ones are in 373? Michael? 373.
No.
You didn't use, no thank you, you didn't use ones to build this number, but you kind of did. You just used already grouped ones. Okay? Go ahead and put your pieces away. Put your math kits up. We're not going to need them for our next. So we are working on the title, which says, what does part whole look like with subtraction? Logan, you need to do that significantly faster. And Gwen said, well, we did part whole yesterday. We did. And we're going to continue looking at part whole. We looked at it a lot when we were doing multiplication and division. We looked at it when we were doing some addition. And we're going to continue to look at it with subtraction. When I am using part whole to subtract, what are some of the pieces that I know? When I'm using part whole to subtract, what do I know? Jackson, get your math book out, please. Sean, what's something that I know? When I'm using part whole with subtraction, what are some of the pieces that I know? So, is my whole blank? Do I not know my whole when I subtract?
No, one of the parts is
I'm usually missing a part. I'm going to draw a bar. If you haven't drawn a bar in your notebook, go ahead and do so. One of my parts is missing in part whole.
the whole.
I always know my total.
What's the total?
I always know my whole or my total. Let's pretend, just for this problem, that my whole is 10.
Oh.
So I always know my total because if I'm subtracting, I need to know what I have. Right? If I'm going to start giving away anything, I need to know how many of those things I have before I can start passing things out. What could be the part that I know?
Ooh.
What could be the part that I know? Notice I already told you the whole was 10. So what could be a part that I know? Well,
9.
could be 9, right? That would work. Because if my part is 9 and my whole is 10, that makes sense. What else could my missing part, or not my missing part, sorry, my part that I know, what could it be? Harper?
3.
Could be 3. Elena?
5.
5. Shelby? 1. Nope. Clayton?
4.5.
Could be 4.5. Sean? 2. Michael?
Any number up to 9.
Any number up to 9. Why did you say up to 9?
Because if it was 10, it would be 10 plus 0. And then it will still be 10. So
Could it?
I guess it could.
Okay, so it could be 10, but what about 11?
No, so it would be 11 and then
Wait.
1. Oh, wait, so that would be right.
It could be 11.
No, wait, because this.
Could this right here be 11?
Yes.
Yeah.
Yeah. Because you can minus 1.
What is this?
10.
What does that 10 mean?
Your whole.
What does it mean? Bella? I have 10 things. So if I have 10 things, go sit down. Could my part be 11?
Yeah, you can see that.
No, it cannot. I only have 10 things. I don't get any more things. So Michael, you're right. It has to be less than my whole. It cannot be 11 things because I only have 10 things. That's what this number is telling me. Yes?
We're doing subtraction or addition.
You tell me. It still looks the same. Whether I am subtracting or adding, part whole still is the same thing. I just know different pieces.
You can do like 11 minus 1.
If I did 11 minus 1, 11 would have to be my total. Does that make sense? Okay, so let's say that this part right here, how about 6? With subtraction, we start with all the things, right, Bladen? So I'm going to start with my whole. What is my whole? What is my whole, Elena? 10. And then I'm going to subtract the part that I know. What is the part that I know? Harper? 6. And then I'm going to get that missing part. Gwen, you asked me if we were adding and subtracting. Remember, we could do both. Can you make this an addition equation?
Yeah.
All right, Gwen. See if you can figure it out. 6 plus part equals, what's my whole? Equals 10. So when you are using addition to subtract, you can do that. We've been doing it in our number talk. When you are doing that, it's going to look like that. It's going to say 6 plus that missing part equals 10. And for some of you, when you see an equation like this, you probably already know what the answer is. They would know what that missing part would be without having to count backwards. Maybe you just know it. Brayden?
It is 4.
It is 4. Did you count backwards or did you use an addition fact?
I use an addition fact.
Alright. We're going to move on. We're going to continue looking at that bar model, part, whole. But this time I'm giving you an actual equation, not 10 and 6. We're going to be dealing with some third grade numbers. So go ahead and write that equation. It says 734 minus 327. If you need to. What you need, Gwen?
I think I'll need more than half of it.
Probably not. Yeah. Probably yes. Alright, with this equation right here, we're going to make a bar model. Now, it's kind of silly to make a bar bar model only helps you build an equation. We already have an equation. But I want you to get practice at seeing what it looks like in bar model form and then what it looks like in equation form. Yep. Do we know a part or a whole? Like, what do we know? What's something that we know that we could put on my bar model? 7? Okay, so what am I going to put on my bar model? Where? Okay, is it a part? 734 is a part? It's sum of what I got? It is not sum of what I got. When I subtract, do I start with some of my things or all of my things? If I'm starting with all of my things, is it a part or a whole? It is a whole. This is my whole right here. This is all my things. So does it go in my bar? Nope. Where does it go? There's my whole. Okay. What else do I know? What else do I know? Elena, what else do I know? It is a part. Where are we going to put it? Just wherever. Yeah. What's going to go in this box? Elena?
The answer to number that we don't know yet.
Sure. Could I just put a question mark there?
Yeah. Also, another thing we need.
We need some what? I'm sorry?
A minus symbol.
Not in our bar model. Our bar model just puts things in part whole so that we can figure out, the equation.
But will it always be adding?
So I can, with this right here, I can make an addition equation or a subtraction equation.
So if you add up and
Do you think you can tell me what my addition equation might be?
yeah.
Jacob, sit up. What is it, Bladen?
327 plus part equals 734.
Okay. Do you think you can make a subtraction equation?
Yes.
What is it?
Our whole 734 minus 327 equals our part that we don't want.
Yeah. You get to decide whether you're going to add or subtract. It's not always a straight up subtraction problem or always a straight up addition problem. On the last one, Braden said, you know what? It makes way more sense for me to just add because I know that 6 plus 4 is 10. For this one, does it make sense to add? Maybe. It might make more sense to subtract. You get to pick the equation that makes your brain happy. Layden, what you need?
I think the answer is, I think it's 407.
Let's find out. Let's do a number line.
Yeah, it's 407.
Do a number line.
It is. New page 407.
Okay, thank you. Same equation. Draw on a number line. In the left one first. You can, and you're gonna break this whole time though. Alright, we're gonna go with subtraction on our number line. We're gonna go backwards. So I'm gonna start with 0. What's gonna be my ending number? Ashlyn? How'd you know that? my whole, all those numbers from 0 to 734. That shows my whole. Yep. Where's my part? Go ahead and turn around, please. Where's my part? Where's my part, Devin? Yeah. I'll put it, how about right here? That work? Why not? So why can't I put 327 there? Can I? Sure. 327. Put it wherever you want. Here's my part. And then here's my question mark. Does that look like what we just made? Does that look like what we just made with our part whole? Do you see it? Yeah. 0 to 327, that's 327. And then we want to figure out the distance or the difference from 327 to 734.
It's 407.
Alright, let's go from 734 counting backwards to 327. What could be our first jump? What could be our first jump, Lincoln? 700. If I do a jump of 700, where am I going to end up? But I want to get to here. So I don't want to go that far. I'm not going all the way to 0. I want to get to 327. What could be my first jump? 7? So we're going to do a jump of 300? Alright. Where would that put me, Devin? What number? 434. Love it. Yes, thanks.
Wait, 430?
We did a jump of 300, got us to 434. Now what?
Oh, wait, not so good.
John, now what?
Do a jump of 100.
Another jump of 100. Okay. What number does that get us at?
300.
Awesome. Now what? Now what? Brayden, now what?
A jump of 10.
Jump of 10. Okay, what is that going to get us to?
324. Wait.
Look at where I'm ending, though. So Brayden's having a hard time right now because he knows that if I do a jump of 10, I'm going to end up at 324. And that is going to be in front of my ending number, so I cannot do a jump of 10. Do you have an idea?
A jump of 10 and 3 ones.
So a jump of 13. So if I jump 10, I'm going to end up at 324. That's going to be ahead of our number.
17.
So if I jump 10, it's going to be ahead of our number. If I jump more than 10, it's still going to be ahead of our number.
Jump 7.
You could jump 7 if you wanted to. That might get us there. Leda, what do you think?
If you want to exactly get there, it's 7, but I would most likely do 4.
Ooh, why are you going to do a 4? That's interesting.
To make a family number, 330.
Love that. Brayden, this might be something that we're writing down, love. So we started at 334, and then we did a friendly number jump to get us to 330. And then to get us from 330 to 327, where do I need to go?
3.
Just 3. All right.
And then it equals 407.
That looks like a crazy number. Is it 3,400, 100, and 300?
No. 407.
Because I got a craziness happening. I need to add up all these jumps. 100 and 300 gets me 400.
Plus 7.
Plus 3 plus 4 is 7.
407.
400.
Do it. You said 400.
You said 400.
407.
You said 400. Some mental toughness right there. Alright, I want you to try this problem using a number line strategy. You can go backwards or you can go forwards. Does not matter to me. But try out your number line strategy.